Okay, in this video, we are going to look at network analysis using two cyber infrastructure tools. The first tool we are going to look at is a CINET, hosted at Virginia Tech, and this is kind of like a cloud based source where you don't have the software running at your local computer. You just upload the data, or you can just select the data, the network data that they have, and they will be able to analyze that over the servers and give you back the results. So it's completely a web based tool. The second tool we are going to look at later is the Gephi tool, which is basically like a software that you will download and install on your computer, an application, and you could again upload the network data in it and analyze the data and get some results. So we're going to see both of these kinds of tools and analyze the results that we get for different networks. So for CINET, you need to have an account because this is a web-based tool. So I already have an account, so I can go ahead and log in. I'll show you how to register for it and get the account too. So click on Tools and then click on Granite. That's the site under the tool is hosted. And then I already have an account, so I'm going to log in. If you don't have an account, you can just simply register, and if you're doing it from an academic institution, you can use that email address as well as fill up your information and send a request. Typically it will be verified, and you'll be emailed back in a couple of days. Okay, so let me log into Granite, and I'm here, so you can have okay, so I have already done some analysis in this tool, so that's why some of them are showing up. So they have different options for the things that you can do. So let's start with a simple thing. So if you click on Networks tab, you will see a collection of networks that they already have stored at the server. And for example, this is the, if you click on this, you see the details of the network. So this is like the US Airlines network. I'm not sure it's just US Airlines or let me see. So here they have described it. This is a communication network where nodes are the airports basically, and there is an undirected edge between two nodes if and only if there's some plane between those corresponding airports. So it's basically a network of airports. And now there could be a visualization component in it. I have already done a visualization for this network, so we could that gets stored here. But for some networks like this, there's no visualization that is already there. And for each network, basically, there's a details that tells you the number of nodes and edges and who contributed to it. Because if you have admin access to this site, you could also contribute some networks, upload them. And also it tells you whether it's a directed or weighted and labeled and connected and all these things. So labeled means whether the nodes have some labels. So it could be like at the airport network, each node is given an ID, or airport is given an ID, but is it labeled like this is some Atlanta airport or some Dallas airport or something like that? Okay. um, so if once you have an account, you could start playing with these different networks, and you could set up add visualization part to these networks. And once you do that, it gets saved in your account. So every time you log in, you open the network, the visualization component can also be seen. And for each network, you could also have different visualizations that could be done. Okay, so I'm going to show you for one a sample visualization. So you have several networks, so you could visit and see all sorts of networks that you have. Okay, and later we are going to see we can also create our own network. Okay, but it cannot be saved in this database, but you can create and then analyze it. Okay, So I'm going to pick up one network, which is the Soccer World Cup network. And what this network is basically is about, I already have done a visualization, but I'm going to show you again how I did it. So it is a directed network. Actually, there's a typo here, so this should be a directed network, but that's okay. We're going to see it eventually. It is a directed network, and it is also weighted too. So there are some typos in this software tool. So it is a directed and weighted network, but they have reported as not directed and not weighted. So let's see what this network is about. So this network represents a kind of like contracts that countries have over their football players. Okay, so each country has some football players whom they can contract to another country. Okay, so nodes in this network are countries, and there's an undirected edge I to J in the network if and only if country I has players contracted to play in country J's domestic league or vice versa. So actually, this is a directed edge because one country can contract its players to another country, but the other country need not contract its players to this country. So this is a directed edge based network, but it has been wrongly reported as an undirected network edge. But that's okay. There are some typos that will eventually get fixed. So this is kind of like a work in progress kind of tool, but it's still kind of very informative, and it has a huge collection of networks that you can analyze in one single site rather than searching for data and analyzing them, okay, over the network, which we'll also see how to do it. Okay, so let's add a visualization component. So let's do it from the beginning. So I would just say soccer analysis visualization 2 or something like that. Now there are different ways you can look at this network of these countries for this network. Typically we use either the force atlas one or the ifan who, and sometimes you can also combine ifan who and force atlas. So it'd be interesting for you to just go and play with the different layouts, and you can even Google up and see what these different layouts are doing. So they present the graph in a different format, layout basically, the way it looks visually. And some layouts may give you more better visual appeal compared to other layouts, and also depends on the network actually. So there's no particular layout that will be the best to visualize for all sorts of networks. Each layout will be good for different networks. Okay, so let's try with this. Now, CINET can kind of display the network for different, like the nodes can be of different colors, as well as the size. The nodes can be of different size. So there are two ways you can vary the way how the nodes are presented. So this way you can capture not only just a simple graph of this nodes, we can capture in metrics like the nodes having high degree can be of one color, nodes having a low degree can be of another color, and so on. So let me base the color based on degree. So you can even choose the color you want. I can say I want this color for different nodes, for one set of nodes. Basically there are only 3 different colors we can use in CINET, but in Gephi, which we're going to see later, we can use different colors. Actually it would be good if your colors range from dark to something which is very pale. So let me pick up these if possible. Let's see. Okay. Alright, so I'm not going to use the edges because let's try it. This is a weighted graph, so but it's reported as not weighted, but you could use weighted graph color. don't need to use colors for even the edges, because then it will be too confusing, because you're coloring the nodes too. So now for the node size, we can use one of these two, degree or betweenness. Since we already used degree for the color, let's use betweenness, centrality, as a measure. And this controls how large your node could be. So your node could be even, say, something like this size. So we'll see the impact of it. So a request has now been submitted just over the web. There's nothing that's downloaded running on your computer. Everything's done over the web, and now the processing is happening at the server side, and eventually you could see that a visualization component will get added. So you can see there are different visualizations now. One which I've already done, and this is the one that I'm currently running. Okay, and most of the time it will not take much time to get the visualization done, but sometimes it does take a while, depends on the server load. And so if several people are requesting or doing something at the server, then it may take some time. Okay. So in the meanwhile, let's go and do some analysis of this network. I already done an analysis of the soccer network, but let me do one new one. So click on new analysis. You can say soccer network analysis or something that is relevant to what you're trying to do. Since I already done one, so I'm just labeling it as version 2. So I'm going to continue. And then you can add, of course I have not yet selected the network, I just labeled it. So I'm going to first, let's say before doing the measures, let's go ahead and select the network. Since the network is already here, let me go ahead and select it. You could even compare multiple networks, which I'm not showing, but you could do that. Okay, this is where Soccer World Cup is. So I have selected it. So now let me go ahead and add the measure. So what metrics I want to select. So there's several metrics you could do. This is actually a good thing about CINET. There are a lot of things that you could evaluate, analyze. So you can find what are the articulation points of the network, betweenness, centrality, and several other things. If you're interested at average neighbor degree, so this basically calculates the for a particular node, it has its neighbors, right? So it finds out the average degree of its neighbors. Okay, so this could be like if you're connected with a node that has a very high average neighbor degree, then you're basically could be considered to be connected well to the rest of the network, or a major or to the major portion of the network. Okay, so let's do that too. And then you could also check if the graph is bi-connected, the graph is bipartite, several other graph properties that you could check for. Graph is Eulerian. Okay, and we could also compute the degree distribution if you want to. Okay, I think the more you request for, it might take more time, but it should be okay. And you could also find out the hub and authority scores of your nodes in the network. You would compute a page rank based thing, and so several other things you could do. Okay, so I'm going to go, and whatever you selected shows up here. You can save it, so it saves as part of an analysis. And I have not yet started to analyze it, so now click here to start analyzing it. You can continue, analyze it. Okay, so it says in progress. So let me meanwhile go back to my network and see if the visualization is done. So the thing is, once you leave that visualization part, you have to again go back to that network and see if the visualization is ready. Okay, so let's go to the soccer network and see if it is ready. Okay, I think this is my new one. Okay, alright, so if you click on this, you can also see the thing. So if you click on Vis description, you can uh, find out what was the underlying thing behind this, like the different options we selected. So we selected this iPhone Who and Force Atlas options together, the layout options together. Then the nodes were color based on the degree. So the nodes are colored based on the degree, and this guy, node 10, has probably the largest degree. CINET is not clear on the assignment of the colors, but you could see the lighter ones, or the nodes with low degree, actually, like guys like this, have this light green color. So, or light green means, I think this yellow color could be there too. Kind of yellow, light yellow color. Then this one is light green. Okay, the green color that we selected here. Then this is the darker one. Okay, so this is, and you could visually see it has very high degree. Okay, and this could also mean that it has very high degree, but as you see, this node has a high degree too. But so but essentially it gives you a color mapping of the nodes with different degrees. And the other thing is the size of the nodes. So the nodes with a high betweenness centrality could be very big, like this node has very high betweenness centrality. This node relatively has low betweenness centrality. Okay, because if you look at the size of the circle is relatively less compared to this. So this size parameter is working very good in CINET. It can show you the different nodes with different sizes based on the metric that you select here. The metric that we selected here is the betweenness, and the nodes that have low betweenness are sized like this. Okay, now we could go and add another visualization, and let's say we could say just visualize this based on the degree. Okay, and let's just go here and say I want to look at them based on the degree. Okay, and see what is going on. So in the meantime, let's go back to the analysis. It is still in progress, now it's just completed. So let's look at the, click on view report. So that will give you a report on everything that you have requested for. So we requested for articulation points. If you click on this, you get three things. The output is typically stored here. So basically vertices 14, 28 and 10 among the 35 vertices in this graph are the articulation points. So if you remove even one of them, the graph gets disconnected. Now this shows you the average neighbor degree for every node in this network. So basically for the nodes 1 to 35, this is the average degree for every node, and you can get the degree distribution. So basically for each node, what is the degree, that's what it's showing up. Okay, and let's see, and this one gives you the percentage of nodes that have a specific degree. So this you can use to plot graphs and visualize it. So the degrees of the nodes ranges anywhere from 1 to 19. There are 35 nodes, and the degrees of the nodes range from 1 to 19. The larger values which are seen around this range, 3 and 4, and then these two values of the degrees. Of course, it's not like very regular. If you plot it, you can see it increases, decreases, again increases, decreases, and so on. Okay, now we can check if it's what did we check here? If the graph is biconnected and you click on log dot out, it says it's not biconnected. If it is bipartite, it is not bipartite. If it is Eulerian, it is not Eulerian, and so on. You can also look at the hub authority scores of the vertices. So for each node, you can see the hub score and the authority score. Similarly, you have the page rank results, okay, for each node, and then so it can give you lots of useful information. And if you click on download, the results get downloaded. Okay, and actually the results gets downloaded for the one that you have selected. So I am currently in page rank, right? So if you click on download, you get the results for page rank. Okay, so that's what it is. And all these things you can output as log files and visualize it separately. So one thing that CINET does not support currently is you cannot right away visualize these results. You have to copy them to another visualizing medium like Excel. You could use Excel to draw these graphs, as we will show, and look at how the results are looking like. CINET just gives you the numbers. Okay. Of course, it can give you very good things like graphs, properties, but it's kind of biconnected, whether it is Eulerian or whether it is what else, bipartite, and so on, and articulation points, which most of the other software which I have looked at, it does not give you that easily. So let's look at the network back and see if we can visualize the degree. Okay, so I'm in visualization. This is, yeah, so this is my degree component. So here I have I did not color the nodes, I just based on the sizes. It looks like this guy is the most having the largest degree. Okay, if you look at the problem is you cannot open it more than one thing. So you can save it, save the image as something. Okay, okay, so this is degree based stuff. Okay, so let's try this. Remember, this is a cloud-based thing, so everything is being running over the internet. All your commands are sent over the internet, so it does take some time for once you click something, it won't appear right away. Okay, the click command has to go to the other side, and then the results have to be displayed. So that's why it does take a little bit of a time. Okay, so this is the other layout based on the betweenness centrality when we size the nodes, and let's save it. So this is based on the betweenness centrality. I hope I can look at the two files. Let's see. I thought I saved as a PNG file, but let's see. Maybe I can print it to something. can take a screenshot of it at least. This is based on betweenness, right? Okay. Yeah, so see, that's the thing, betweenness and degree are not the same. A node having low degree will be could have high betweenness, and sometimes even vice versa. A node having high degree may have low betweenness. Okay, so I think CINET doesn't still fix these things. You see, also I noticed that these are different from these. Okay, so I would suggest to stick on to this what displays here rather than opening it in a bigger size like this, because it seems to not correspond to that. Okay, so let's just analyze like this, and we cannot even save it to a PNG file. So let's look at like this. Okay. Okay, at least we can visualize it based on the node size and the colors. Okay, we can assign two properties like the degree and the betweenness. So now let's go back to the network analysis thing, and we just saw that since you have saved it, it gets saved in your account. So anytime you want to look at it, you can look at it. Okay. Later we'll also see that we could generate even networks. Okay, another project, but let's look at this also right now. So you can click on new network generator. You can generate a network that you want. So I just say my network, which is say a random network I want to create. So you could create networks according to the different network models. So I could just create a random graph. So what this does is it creates this Eddos-Renoy random graph model with a particular number of nodes, and there's a probability of P for an edge to be between any two vertices. So you can choose those numbers, what are the numbers you want, and you can submit it, and actually you can save it and then generate it. So it will be generated now, and you can again once it's generated, you can look at it what it is. So this should be the network. Let me see. Maybe this option is still not running. Okay, where are my networks? It's here. Okay, so let me look at this. We created the network, right? Okay, it's here, but let's see. Okay, it does take a while to get those numbers from there. So this is a random network. So these two, the first two columns are the node IDs. So there's an edge from node 0 to node 1. These are could be the weights of the edges, but I have not specified anything. Assign it right now currently does not facilitate adding weights for the edges like this, but later we could add. So there could be a feature to add the weights. So in order to accommodate that, the edges are given these two additional parameters that could be the weights and some other metrics that or indicating that that are like characteristic of that edge. So right now we are interested only in the first two columns. Basically, it says as an edge from the originating node to the target node. Okay, and it could be a directed. It is a directed graph. So there is an edge from 0 to 1, and there's an edge from 1 to 0, and so on. Okay, so this is a random graph on these 20 vertices. Okay, so we could generate networks like this, but again we could not we could not we can download it and see, but the download will give you the output like in a text format. We can export that to Gephi. Actually, I'm going to show you how to do that. We can even try on this. So we could export it to Gephi and visualize this network there. Okay, so this is one thing that we can make use of, both CINET and Gephi. Gephi cannot generate networks like this for you, whereas CINET can generate like random networks and different other networks with certain different parameter values. But CINET cannot visualize those networks, and you cannot even analyze the properties of these networks for the time being. People have been now currently working on adding those features in CINET. But in the meanwhile, we can use Gephi or any other network analysis tool to visualize these networks and analyze the properties. Okay, so remember, CINET is still a work in progress. It's not a complete software or an application tool running over the internet. Okay, so that's one thing. Okay, so with this we are typically I have covered CINET and showed you all its characteristics, what it can do and what it cannot do, and the work in progress. Okay, so we'll stop with this.